How long is the journey to Mars? And why is it so difficult to get there? Think about this. Imagine human civilization expanding into space as if it were a child leaping from one rock to another across a river ford. The initial stone or leap which allowed confidence to grow was just 400,000 kilometers from the coast. Of course, we're talking about the moon, a gigantic satellite, conveniently near to home that practically invites us not to be afraid. However, the next stone just rising from the sea is 1,000 times farther than the first, a genuinely terrifying leap. We are obviously talking about Mars. Here the child pauses to reflect. He's terrified, yet he still wants to try. But how? What are the possibilities for success? Simply put, reading certain publications implies that many volunteers are willing to jump regardless of what occurs. But is this true? Has someone advised them that going to Mars is not the same as getting to the moon? Are they aware that the expected flight time from Earth to Mars is several months rather than 3 days? Do they also aware that, due to the geometry of planetary placements, a mission to Mars is estimated to last approximately 2 years, including the outgoing trip, stay, and return journey? If they still don't know, we'll try to explain it in this astonishing video. The mission to Mars should be treated seriously. The child on the riverbank understands this and understandably does not trust it. Neil Armstrong and Buzz Aldrin landed on the moon in July 1969, and Wernher von Braun, the creator of the U.S. space program, estimated transporting men to Mars would take at most a couple of decades. But now we are in 2024. We've launched orbiters, landers, and rovers to Mars, but no one has stepped foot on the red planet. Why? Political motives have declined, particularly the space race between the United States and the Soviet Union. As a result, NASA's budget was reduced to fund other contentious activities, but objectively, there are enormous technical obstacles. Going to the moon only takes 3 days, which means that a crew can survive without the chance of resupply, as demonstrated by the famous Apollo 13 event. Instead, a trip to Mars takes many months one way, with all of the difficulties associated with extended exposure to microgravity, communication delays, exposure to solar and cosmic radiation, and the difficulty of short and medium-term rescue or replenishment. But in actual words, why does a trip to Mars take so long? To comprehend this, we must first consider that Mars and Earth orbit the Sun in two almost round and concentric orbits that are 0.52 astronomical units apart, or approximately 78 million kilometers. Importantly, according to Kepler's third rule, Mars orbits the Sun at an average speed of 24 kilometers per second, far slower than our planet, which moves at 30 kilometers per second. Earth completes a revolution in 1 year, but Mars takes 1.88 years. Before we continue, don't forget to subscribe to our channel if you haven't already, and make sure to turn on the notification bell so you don't miss out on our daily videos. Imagine Earth and Mars as two cyclists on a track, with the outer, Mars, traveling slower than the inner, Earth. One of the many questions that arise in these situations is how frequently the inner rider reaches and passes the outside one. The math is straightforward, indicating that the inner cyclist, in this case Earth, will reach Mars or align with it on the line connecting them to the Sun every 780 days. This means that every 2.14 years, Earth will approach the minimum distance from Mars, which is 78 million kilometers, before passing it and moving away. To make matters slightly more complicated, the orbits of the two planets, particularly Mars, are not perfect circles, but rather ellipses with considerable eccentricity. As a result, the distance at the time of overtaking can fluctuate by as much as 54 million kilometers every 15 to 17 years. Now that we have all of the elements, we can answer the most essential question: which ideal orbits will allow us to reach Mars? At first glance, one may think, well, let's wait until we're at the minimum distance from Mars and then shoot a probe straight at it. No, that is not how things function in space. It would be similar to shooting an arrow at a moving target from a moving vehicle. The target would move throughout the arrow's flight period, and we would miss it by a large margin. To hit the target, the archer must aim at the spot where the target will be when the arrow arrives rather than where the arrow is released. Okay, but interplanetary space isn't exactly like a shooting range. In space, the distances are enormous, and spacecraft and planets move mostly due to the gravity of the sun. As a result, once the initial push is depleted, the universal law of gravitation and the principles of dynamics dictate that a spaceship must follow an elliptical trajectory. And because the planet's orbits are more or less pronounced ellipses, all we have to do is find an elliptical orbit that begins with Earth and intersects the Martian orbit when Mars is close to those sections. The issue is that in order to decrease the flight duration, the engine must be ignited for a longer period of time to boost speed. However, this would necessitate transporting a significant amount of propellant. The greater bulk would necessitate more propellant to be delivered into orbit and accelerated. This condition will endure until we convert from chemical to ion or nuclear propulsion. It is also important to know that a vehicle bound for Mars cannot be increased arbitrarily in speed. Spacecraft must approach slowly enough to perform orbital insertion procedures rather than just passing by their target location. Another question to consider: is it true that a trip to Mars can only be made every 2 years? If so, explain why. In truth, a travel to Mars can occur at any time, but the difficulty resides in fuel consumption and time constraints. Using the simple Hohmann transfer orbit, launch windows are influenced by the synodic period, which is the 780-day time between two maximum near approaches to Earth and Mars. Every 780 days, there is a 1 or more month launch period with launch windows lasting a few hours each. In more sophisticated scenarios, such as gravitational slingshots, and launch times become erratic. Rare possibilities do exist, such as when Voyager 2 visited Jupiter, Saturn, Uranus, and Neptune during a 175-year planetary alignment. However, we are not simply limited by the synodic period for the outward travel. In addition, in the case of a crewed expedition, we would have to wait for the two planets to align favorably before returning. This brings us to the most painful part of a voyage to Mars. The period of an expedition to the Red Planet, including the outward journey, forced stay, and return, could not be less than 15 to 24 months, assuming major energy use. The Hohmann transfer orbit, which has the lowest propellant consumption, would take roughly 8.5 months to go from Earth to Mars, 15 months to station on Mars, while waiting for the perfect transfer window to Earth, and another 8.5 months to return. This comes to 33 months, almost 3 years. This means that astronauts will have to spend almost a year on Mars completely alone with everything that entails before being able to come home. If we include the outgoing and return voyages, we have a mission plan that requires nearly 1,000 days of space residence with a crew of 4/5 people tens of millions of kilometers away. That is why traveling to Mars is no easy task. It demands precise preparation of each project phase as well as the resolution of each mission challenge. And thus, I'd want to advise the apprehensive child approaching the fort: think carefully before leaping onto that distant emergent rock. After all, you can still choose not to cross the river and get home safely tonight. Alright folks, that is all for this video. Thanks for watching.